Good day guys, today we are doing miscellaneous equations. We are supposed to know that if we deal with miscellaneous equation, it's an application of what? Our basic laws of indices. In this case, we'll be converting is either our bases or our what? Our powers to the same, to become the same. In this case, I'm supposed to convert my 27 to be what? To become 3. So that's going to be 3 to the power x plus 2 is equal to 3 to the power of what? 3. Now since I have raised my bases to become the same, I'm supposed to do what? I'm supposed to cancel out. If they are now equal, I'm going to cancel these 3's. Then I'm going to continue with my normal equation. X plus 2 is equal to 3. Then x is equal to 3 minus 2. X is equal to 1. That is my answer. That's the first example of what? Of a miscellaneous equation. Let me move on to the second example of a miscellaneous equation. So I continue there. I've got my second example of what? Of a miscellaneous equation. In this case, since I said I'm converting everything to the same base, so it's supposed to be what? To be 5. So 25 is supposed to be what? 5 to the power 2. Then here there was an x, so it is 2 times what? Times that x, so that's 2x. Then it times 5 to the power 3x minus 2 is equal to, if I'm converting 125, it's going to be 5 to the power of 3. Now I've got bases that are the same. I'm supposed to apply the laws of what? The laws of indices. As I cancel here, I'm going to cancel out my 5. Then here, since these are what? These are powers according to the laws of indices. If we are multiplying, we are supposed to do what? To add our powers. So I'm supposed to put a positive sign there. Then I cancel that side. I'm going to continue with that top equation. That's now 2x plus 3x minus 2 is equal to 3. I'll then collect my like terms. In this case, 5x is equal to 3 plus 2. 5x is equal to what? 5. I'll then divide by 5 both sides. So your final answer is what? X is equal to 1. That is your final answer. Let's move on to the other example that I have here. So as we continue, here is the other example. It's 4 to the power x plus 1 is equal to 1 over 16. This is a 16, not a 10. That is a 16. So we are supposed to first convert that one. So it's going to be 4 to the power x plus 1 is equal to 16 to the power negative 1. Then 4 to the power x plus 1 is equal to, I'm now supposed to convert the 16 using a 4. That's a 4 to the power 2, then bracket negative 1. Now I have raised to the what? To the same bases. I'm supposed to cancel out these bases. I'm supposed to cancel out those bases. In this case, it's 4. Then x plus 1 is equal to negative 2. X is equal to negative 2. Negative 1 is equal to negative 3. That is your final answer. Now let's move on to this other harder miscellaneous item number 4, question number 4, that might require to factor in some other concepts before you move on to the actual question. So there is our other example. In this case, it's 6x to the power 3 is equal to 48. We are supposed to first determine what is either a perfect square, perfect cube, or anything like that. So in this case, we have to say 6x to the power of 3 is equal to 48. We are going to divide by 6 then we'll cancel here. 6 into 48, that's what? That's an 8. Then x to the power 3 is equal to 8 there. Now there is a critical concept that I want you to understand from this stage. If we are looking for this x, we have to know that this x here, this 3 is always over 1. So we are going to multiply it by what? 1 over 3. What we use on this first side, we have to use it on the other side. So it's times to the power 1/3 there, like that. So that these are going to cancel out. we're going to obtain x is equal to 8 to the power of what? Of a third. Then you're going to apply what? Your laws of indices that side. You're going to apply your laws of indices that side. So in this case, we're going to have x is equal to 8 third root of 8 1. So x is equal to 2 to the power 1. X is equal to 2. That is our final answer. So that is an example of what? Of another harder miscellaneous. That is an example of another harder miscellaneous. So let's try to check this out from some past exam question papers that I have here. Let's try to check it out. So as we proceed, I've got November 2009 here. November 2009. Here is our miscellaneous equation. Our number 2, item 2. There is the question. Solve the equations. So we are solving item 2. That's a miscellaneous equation. We convert everything to what? To equal bases. We convert everything to equal bases. So let's try to solve this one out. We're going to have 3 to the power m plus 4, which are in what? In brackets, are equal to, I have to convert that 9 using a 3. That's a 3 to the power of 2. Then there were brackets which were containing m minus 1 close. I'm going to cancel out those 3's like this. I'm going to cancel them out here. Then I'll proceed with that m plus 4 is equal to, I'm going to expand there, 2m minus 2. I'll then collect my like terms. 4 plus 2 is equal to 2m minus m. Then 6 is equal to m. Then if you, whenever in maths, if you work your answer and it appears to be like this, it's still incomplete, then you are supposed to indicate by saying therefore m is equal to 6. This is now your final answer. That is now your final answer. Let's move on to the other question. That's our November 2002. So this is the question paper that we are now doing, November 2002. There is the question. It's number 9b. Number 9b. Given that, so we're given that question, we are supposed to create a quadratic equation. So that's 3 marks for just showing. Since the question says show that, we are supposed to indicate on our final answer that we were showing by saying shown. So there is the question. There is the question. I'm going to copy it down here and say I'm now solving it. Since I have copied the question, it's now 2 to the power 2, then bracket x squared minus 3 times 2 to the power 3x is equal to 16. It's simple. Again, I have to convert the 16 and raise it to the same base like these other two. So it's 2 to the power 2 bracket x squared minus 3 times 2 to the power 3x is equal to 2 to the power 4. Then here I'm supposed to introduce a sign. Since I want to cancel out here, I'm going to put a positive sign there. Then I cancel these twos. I'm going to proceed with that one. 2 bracket x squared minus 3 plus 3x is equal to 4. Most of the students tend to forget to put that positive sign. They will continue that with that multiplication sign, of which that's automatically wrong just because you didn't apply the concepts of what? Of indices there. And now expand there. That's 2x squared minus 6 plus 3x is equal to 4. Since I'm supposed to create a quadratic equation, let me try to collect my like terms. 2x squared plus 3x minus 6 minus 4 is equal to 0. I'm now moving on to what? To my final answer here. That's now 2x squared plus 3x minus 10, that's equal to 0. Since the question here demanded me to do what? To show, I will then indicate on my final answer shown. This is my final answer. You will be done there. That is your final answer. You will be done. Since the question demanded you to show that, so you have answered the question. This is so simple. These are called miscellaneous equations. Let's proceed to the other question paper. So here comes the other question paper that I have. Is June 2019. Here is the question. It's number 20A. There is the question. Solve the equations. X to the power 2/3 equal to 4. X to the power 2/3 equal to 4. I've copied the question below. Let's try to work this question out. In this case, it's x to the power 2/3 is equal to 4. Now, if you want to eliminate this power, we have to convert it. So I'm going to come here and say x to the power 2/3 times, let me use this different ink so that you see the converted one is times 3/2. This one that I use this side is the same that I'm supposed to use on the other side, to the power 3/2. Now these are going to cancel out. I'm now left with x is equal to 4 to the power 3/2. I'll then apply my laws of indices here. So it's like that. So it's x is equal to second root of 4. That's what? 2 to the power of 3. X is now equal to what? 8. Since you know how to prove an equation, it's still simple. You can still prove this 8. Put that x, put this 8 where there was an x there, and apply laws of indices. You are going to obtain what? That 4. Let's proceed to the other question, which is November 2001. This was the cheapest. November 2001. This was the cheapest question. There is the question. Given that 5 to the power x equals 125, find the value of x. That is the cheapest question. It's November 2001. Number 4b. If 5 to the power x is equal to 125, so 5 to the power x is equal to 5 to the power 3. You will then cancel your bases just because they are now the same. Just cancel. So your x is equal to 3. That is your answer. You will be done. Let's move on to the other question. It's November 2015 paper 1. So there's the question that we are doing. It's November 2015. That is number 16b. There is our miscellaneous equation. Find x if. So it's find x if. There is our question. Let's try to do that question. I've copied below. So we have to first convert everything to that, to the base of 3. This 9 is going to be 3 to the power of 2. Then bracket, just because there were other terms there, times 3 to the power of 3x minus 2 is equal to 3 to the power of 1 there. Then I'll have to do what? I'll have to cancel my bases here. I'm supposed to cancel my bases since they are now the same. As I cancel, I'm supposed to do what? To put this positive sign there. Make sure you never forget to put that positive sign, just because most of the students tend to continue with this multiplication sign. So my new equation is now 2 bracket x minus 1 plus 3x minus 2 is equal to 1. Then I'll solve this one out. I'll expand 2x plus 2 plus 3x minus 2 is equal to 1. I'll then collect my like terms. 2x plus 3x is equal to 1. This was a negative sign there. Realize the mistake that I made here. 2 times negative 1, that's a negative 2 here. That's a negative 2. It's not a positive, so that's our negative 2 there. Then it's now 1 plus 2 plus 2. You see? It's now 1 plus 2 plus 2. So it's now 5x is equal to 5. Divide both sides by 5. Divide by 5. So your x is equal to what? 1. That is your final answer. Your x is equal to 1. So let's do this other question. It's our November 2014. That is a replacement paper. November 2014. That is our replacement paper, if I'm not mistaken. So here is the question. If 32 equals 2 to the power m, find the value of m. If 32 equals 2 to the power m, find the value of m. It's also a cheap question. It's number 7a, which says 32 equals 2 to the power of m. So it's simple. I just convert that 32 is 2 to the power of what? 5 is equal to 2 to the power of m there. It's equal to 2 to the power of m. I'll then do what? I'll then cancel my bases. So it's now 5 is equal to m. As I said, you'll be not done. As long as your answer appears to be in this format, you're supposed to say, therefore, m is equal to 5. You'll be supposed to rearrange your final answer. So these are miscellaneous equations. Let me give you harder miscellaneous. Mostly harder miscellaneous. I've seen some harder miscellaneous from Cambridge exam question papers. So these harder miscellaneous, they may appear in the form of what? In the form of decimals, and also even these fractions, but they will be containing some negative signs. Let me give you some examples. So I've came across this question. I've come across that question. So what you have to know is that we are supposed to first convert that one into what? Into a fraction. I think we all know that fraction. So it's going to be 2x to the power 3/4, which is equal to 16. I'll then do what? Divide both sides by what? By 2. Instead of doing what? Instead of raising it to the same base, just because I'll still need to divide. So that's equal to what? 8. So it's now x to the power 3/4. It's equal to what? 8. Then I'll be forced to do what? To convert that one. X to the power 3/4 is supposed to be times what? To be times 4/3. Just because I've used this one, even on the other side of the equal sign, I'm supposed to use 4/3 here. So that I will cancel there. So now x is equal to 8 to the power 4/3. Then x is equal to, I'm going to apply my what? My basic laws of indices there. 8, 3, 4. It's now going to be x is equal to 3/8. That's what? That's a 2. Then to the power 4. Then x is equal to 16. That is our final answer. So you might find some questions, they might require you to determine the base. Let me give you an example of such a question. So there's the question. X to the power of 3 is equal to 8. In this case, I'm supposed to deal with this question like this. X to the power of 3/1 is equal to 8. Now, if I want to remove that 3/1, I'm supposed to say x to the power of 3/1. Then I will multiply it with what? With an inverted fraction terms 1/3. It's equal to, I'm going to use this one again, that side, 8 to the power of 1/3, so that these are going to cancel out. So it's now x is equal to 8 to the power of 30. Then I'm going to apply my laws of indices here. 30√8 to the power of 1. So my x is equal to 2 there. That is my answer. So I think you have seen we've got miscellaneous equations that appear in the form of what? With some decimals. Some might appear requiring you to first divide. So that is the last concept of what? Of miscellaneous equations. That is the last concept of miscellaneous equations. So we are going to end here with our miscellaneous equations. So as we continue, we are going to continue with indices and logarithms. It's still the continuation of what? Of those laws of indices. Actually, we are going to continue with the standard form and logarithms. We're going to continue with standard form and logarithms. So we are left with two topics that apply these basic laws of indices. So take note of this concept and try to practice a lot to see where there are similarities and dissimilarities Thank you for your time, guys.